Okay, so here we have a wrench that's turning. You're like, that's not bad for a 2-second diagram there. And this wrench is turning this bolt on here, and the angle of inclination is going to be 19 degrees.
Okay.
And the force that this boot puts down is 900 newtons.
Mm-hmm.
And this lever arm is 0.8 meters.
Okay. 0.8 meters.
Okay, so the question.
Situation, find torque.
Yeah, so find the magnitude and direction of the torque applied to the center of the pipe fitting.
Okay.
So pipe fitting, so that should be circled on a hexagon. Go ahead. Tell me what to do.
All right. They give us the force. They give us the radius. They give us the distance, the L. And they give us an angle. And one of the ways we can find the torque is the radius multiplied by the force times the sine of the angle. Since the sine of the angle isn't 90 this time, we can actually use the sine. So
now I want you to be careful though, because our actual angle between our lever arm and the force is not 19 degrees.
That's only for the lever arm at the end of the pipe.
Correct. What else is there?
There's an angle there.
I think we should draw a free body diagram. So here's the contact. Here is where we're actually pointing towards. Okay, so this is the 19 degrees. As a result, because we know the angles must add up to 180 degrees, we got 71 degrees there. This is the 0.80 meters. This is some unknown distance. We know that the force going down is 900 newton. Is this perpendicular to our lever arm?
Not exactly perpendicular.
No, right? So if I extend my lever arm, let's look at it this way. So if I extend my lever arm past where the contact is, okay, the angle I am searching is for this angle, the distance between the 900 newtons and the lever arm in a positive clockwise counterclockwise direction. Okay.
Right.
So if I'm looking at that, what is that angle?
That angle is 100. The angle that you just made, the yellow one, is 180 minus 71, so 109.
109. Good. Or you could have said to yourself that this is a 90-degree angle. This is 19 degrees. So 109. Either way you get there. So the main angle we're concerned with, actually this should be a phi in that equation. Okay? So now that you got that, all we got to do is some plugging and chugging, right? Okay? So let's do this. Let's first figure out what this distance is. And that would be obtained by doing what? How would we find out?
Let's see. Let's see. You got the hypotenuse. Shouldn't it be cosine instead? Because that's adjacent relative to the 19 degrees.
Yes, it would be cosine. Or cosine of theta equals what? Opposite?
Adjacent. So L
over
0.8.
So when you do that, you should get the sine of 9 times that 0.8 meters, which also equals the sine of 0.8 times the sine of 71, which you would agree with that one, right?
Yeah, I can agree with that.
Yeah, okay. Because the sine would be the opposite over this one, which would give us the same answer.
It would. You guys hopefully wait to find the same answer as well. Pretty up, anyway.
So we should get what,
0.79?
6 is what I get.
76? Wait. Well, I'm in radians, that's why. Yeah, it's 0.76.
Okay, good. So now we can find the torque.
Okay, awesome.
So now that we found this lever arm, we can deal with this perpendicular direction and just multiply. We found a perpendicular component. So now we just take torque as the 900 newtons times. So now that we've converted it, it's no longer a cross product because we applied the sine of phi. And when you do that, you should get 680 newton meters.
Yep.
Good to go?
I'm good to go.